Hey, how's everybody doing? Today we are going to learn about the real number system. All right, first thing we need to know is we need to know the difference between an irrational number and a rational number. So how is an irrational number different from a rational number? Well, a rational number, those are numbers that can be written as a ratio or a fraction. You see, rational starts with ratio. They can be written as a ratio, and a ratio is another thing as a fraction. Irrational numbers are numbers that cannot be written as a fraction. These numbers cannot be written as a fraction. They are off on their own. They are irrational. They're crazy. All right, so what are some examples? Some examples of rational numbers could be any number you can really think of, any whole number, like 4. 4 is a rational number. And the reason why 4 is a rational number is because we can rewrite that as a fraction. We can write that as 4 over 1. Another type of rational number could be a fraction, like we were talking about, like 3/5. That's a rational number. Another example could be, I don't know, let's say 25%. 25%. Because 25% can be written as a fraction. 25% would be 25 over 100, and then I could simplify that down into 1/4, which is a rational number. So rational numbers are numbers that can be written as a ratio or a fraction. All right, irrational numbers are numbers that cannot be written as a fraction. These are numbers that are decimal numbers that go on forever and ever and ever and do not repeat. All right, so that's a key thing. So repeating the fractions, like 1/3 is a rational number. If we put that in our calculator, and I do 1 divided by 3, 1 divided by 3, I see I get 0.3333 repeating. So if I have a repeating decimal, that is a rational number, right? Irrational numbers are decimals that go on forever, that do not repeat, and you cannot be written as a fraction. So what do I mean by that? So, well, do you remember when we were doing perfect squares, right? And we had some that were not perfect squares. So let's say like square root of 8. That is not a perfect square because it gives us this big long decimal, right? So that would be an example of an irrational number. So let's write that down as one of our examples, like square root of 8. Another example could be like a big long decimal, like 3.742118, and that kind of goes everywhere and kind of keeps going on and on forever, ever. These are your big long decimals that fill up your calculator, that do not repeat, and they cannot be written as a fraction. That is an irrational number. All right, go ahead and pause the video. Try and do this down here on your own. It says circle the rational numbers and underline the irrational numbers below. So look at these numbers, circle the rational ones, underline the irrational ones. Unpause it when you're done. All right, hopefully you paused the video. Here are the answers here. So the ones circled are rational numbers. 0.5 can be written as a fraction. It can be written as 1/2. 1/2 is a fraction. -5 can be written as a fraction because it could be -5 over 1. 97 can be written as a fraction, 97 over 1. -7/9, that's a fraction. That is a rational number. Repeating decimals, we talked about that. 0.3333 is 1/3. That's a rational number. And 0 is a rational number. So all those are rational numbers. These ones that we underline are irrational because they cannot be written as a fraction. They're big, long, huge, crazy decimals, and they are very irrational. All right, so when you think of the real number system, you want to think of irrational numbers and rational numbers. Irrational numbers are their own subset. They're their own thing off to the side. Rational numbers, however, have other subsets that are inside of that. So inside of rational numbers, there are other subsets. The first subset inside of rational number is integers. Integers. And integers are positive and negative whole numbers. So positive, negative whole numbers. So type an integer. Let's see here. An integer could be -6. That's an integer. 4 is an integer. Let's see. 18 over 9 is an integer, because if I simplified that, that would equal 2. 2 is an integer. The square root of 16 is an integer, because square root of 16 is 4. The negative square root of 49 is an integer, because that would be -7. Anything that you solve and you get a positive or negative whole number, meaning there's no decimal or no fraction, that means it is an integer number. The next subset inside of rational numbers, so it goes rational numbers and then it goes integers. The next subset after that is called whole numbers. Whole numbers. Whole numbers. All right, so it goes rational numbers, integers, and then whole numbers. And whole numbers are positive whole numbers and 0. So what do I mean by that? Well, 0 is a whole number. All right, 7, 163, 27 divided by 3. 27 over 3 is a fraction, because that would simplify down to 9. Anything that becomes a positive whole number or 0 is a whole number. Negative numbers do not go in this section because those are integers. Okay, so we have rational numbers, and then inside of that we have integers, and then inside of that we have whole numbers, and then there's one more that's inside of that, and that is called natural numbers. And natural numbers are positive whole numbers, otherwise known as counting numbers. 0 does not go into natural numbers. That is only a whole number. So natural numbers or counting numbers are numbers you would start counting with. Like if I was going to count the people in this classroom, I would go 1, 2, 3, 4, 5, 6, and keep counting, right? So it's 1 to infinity, all positive whole numbers. So some examples could be 7, 10, 67, 93. All these are natural numbers. Okay, so this is what the real number system looks like. You will see this is a type of Venn diagram. You'll see this a lot on tests, quizzes, SOL, all that stuff. But it looks like this. Right? We have the real number system because all the numbers that we deal with in math are real. So every number we deal with is part of the real number system. They're all real numbers. All right, from there we have rational numbers and we have irrational numbers. Right? That's what we broke it down to at first. So irrational numbers are kind of off to the side. They're their own little thing, right? That was like pi or square root of 2 that went on forever and ever and ever and didn't repeat. Those are your irrational numbers. And then rational numbers has the subsets inside of those. So like rational numbers were your fractions, it was percents that could be put as a fraction, like 62%, or -7, right? All that stuff is are rational numbers. And then inside of rational numbers, we had the integers, and those were our negative whole numbers, like -7, -14, -2, right? And then inside of that, we had our whole numbers. And whole numbers, the only whole number that's by itself in whole numbers is 0. But its whole numbers could be positive or negative, or sorry, positive whole numbers or 0. And then inside of natural, we have our positive numbers, like 1, 2, 3, and so on. All right, so inside of rational, we have integers, and then we have whole numbers, and then we have natural numbers. All right, let's take a look at this. It says, what is the smallest subset these numbers would go into? So I have some numbers here. See if you can pause the video and figure out what is the smallest subset they would go into. Unpause the video when you are done to see how you did. All right, hopefully you pause the video, and here are the correct answers here. So 0, the smallest subset it would go into would be whole numbers. -6 is a negative whole number, so that goes into integers. 62%, if I change that to a decimal, will be 0.62, which I can put as a fraction, so it's rational. Repeating decimals are rational. Pi is that big long number that goes on forever and ever and ever and does not repeat, so it's irrational. A fraction is always rational. 1 is a counting number. It's our natural number, so that is natural. All right, so let's do this next one here. It says identify all subsets the numbers belong. Put an X in the appropriate boxes. So let's do one for an example. Let's do 1/9. It's like halfway down here, 1/9. So 1/9 is a fraction. So a fraction cannot be natural. So I know that can't be it. It's not a whole number. It's not an integer, but it's a fraction, so I know it's rational. If something's rational, it can't be irrational, but it can be real. All the numbers we deal with are real. All right, so pause the video, try this on your own, and see if you can do it. Unpause it when you're done, check your answers. All right, how'd you do? Here are the answers. All right, square root of 6. So if I put that in my calculator, I get a big, long, huge decimal. That is an irrational number, but it's still a real number, right? It's still a number we can work with, so it is real. Square root of 4, this is a hard one. Square root of 4, if I solve that, I get 2. Well, 2 is a natural number because it's a counting number. Natural numbers are also whole numbers. Whole numbers are also integers. Integers are also rational. And rational numbers are real. All the numbers we deal with are real. Negative 6.5. So negative 6.5 is a rational number. It can be written as a fraction, and it is real. It is not an integer because it has a decimal. Integers are only positive and negative whole numbers. 1/9 we already did. 60% can be written as 60 over 100, so that means it can be written as a fraction, so it's rational, and it's also real. 0 is a whole number. I kind of remember that because whole and 0 looks like a whole. So it's a whole number. Whole numbers are also integers. Integers are also rational, and rational numbers are real. 66. 66 is a natural number. I can count to 66. 1, 2, 3, 4, 5, 6, all the way up to 66, right? Natural numbers are also whole numbers. Whole numbers are also integers. Integers are rational numbers, and rational numbers are real. And the last one, negative 1.0. Negative 1.0 is the same thing as negative 1. And negative 1 is a negative whole number, so therefore it is a integer. Integer numbers are also rational, and rational numbers are real. All right, so that is the real number system. Hopefully you did well on that. If you ever have any questions, please ask a teacher. Have a great day.